Assalamu alaikum. This is Dr. Tariq. This video is about the project conducted by Rabia Rafiq for the Machine Learning 1 course under the MS in Data Science offering at IBA. And this project is to monitor the landscape for tea brands on Daraz. So we have one very famous retail company which have a tea brand, and they want to compare their prices with the tea brands for their competitors. For example, we can have the Tapal tea brand, and we also have Lipton. Similarly, we have Kohinoor, and we have several other tea brands. Okay? So for the company, which the name of the company will remain anonymous, we want to monitor the prices of the tea products of that company with the prices of tea products of other companies. And this is a very complicated problem because it involves lots of data wrangling. And then we also have to, the problem was also to forecast the tea price on Daraz, particularly for the other competitors. So this is a semester project and a lot of work done in this project, as we'll see now. So this is done by Rabia Rafiq. So I'll just skip this part. So the name of the company, as I told you, will remain anonymous. So I have named that as ABC. And our goal here is to actually analyze the pricing strategy in comparison to its competitors, particularly on Daraz. And the company partners with various e-commerce platforms. And obviously, when you have competitors, then you want to monitor the price that they're giving so that you try to maintain competitive prices. So you want to track prices and analyze trends, and hence you can do targeted decision making for your customers which are buying on Daraz. And the overall objective is to ensure how the data can be used to do the analysis and to apply ML algorithms and time series forecasting for predicting the prices of tea. So we have used data from Daraz. In fact, the student has scraped the data from 19th August 2020 till 20th of March this year, 2021. So 9 months data, which is quite a lot of data. And we have shampoo, soap, and tea. But in this project, we are focusing particularly on tea only. So we have already talked about the corporate domain. And the problem statement is to understand the competitive landscape of tea listing on Daraz for major brands. So that's a very, very big thing these days because Daraz is becoming a very powerful platform, as are the other platforms. And it's very important to do this sort of a comparative price analysis. Tea brand managers face an issue in deciding the price of Lipton every month or for any other brand. Price forecasting for Lipton and major competitor Tapal will give the business understanding of the price trend and allow the company to price their products accordingly. So the brand managers are facing an issue in deciding the price to put on Daraz every month. So that's a big problem. It's not like the customer churn problem or a loan giving problem or a marketing problem. So this is a very dynamic type of problem or a streaming type of problem, which is occurring maybe every week or every month. So first, we're going to be talking about the background knowledge, which I have always stressed to my students to actually gather this knowledge. So the company partners with various e-commerce platforms to sell its products, but the major platform is basically Daraz. And the scrap data, the aim is to monitor the tea products and the competitor information, and hence do the competitor pricing and informed decision making. So the data that was scrapped is, unfortunately, it's not possible for me to show the data because it's specific to that particular company. It's private data, but we have lots of information which will allow the viewers to infer what the data was like. So there were limited columns available in the data set for analysis. That's one problem. And the column product name had a lot of information within one column to split. So we know that the SKU name, typically in a retail problem or a retail warehouse, is a very long string. Okay, so it's very difficult to understand the product with that long string. So that's why we have this product hierarchy in warehousing, which absolves us from this long string. We don't want to do anything with that. In this case, we don't have a warehouse, so we needed to classify this product name in some way so that we can do away with this long string. So that's the problem. So the information included the SKU name, grammage, discount offers, etc. Okay. Data is scraped from Daraz, and there was also, in some days, there was this logical error due to blocked IPs on Daraz, due to which we did not have the data for several days. So that's one problem which occurred during data collection. And while doing the analysis, we saw that there are like around 1600 SKUs, and obviously we can't analyze each SKU and make a forecast for it. So we had to select just a few SKUs, which were the more prominent ones and the more significant ones. For example, I can select the SKU 100 gram. I can compare Lipton 100 gram with Vital 100 gram and Tapal 100 gram and Kohinoor 100 gram. And then I can just try, make my analysis of what's happening to these prices. So that's the business decision making that we had to do, as the range of SKUs varies greatly from very small tea bag variants to big 1 kilogram packs and bundles. So maybe you can say that the tea is coming in maybe 15 to 20 different formats and 15 to 20 different weights and package sizes. So when you want to do competitive pricing, you have to be very, very specific on the weight and the type of packet that you want to say for comparison. For example, you can decide to take the plastic bottle of half a kg for all the tea brands, or maybe you want to take the bag, for example, for 1 kg for all the tea brands, or maybe you just want to compare their tea bags, etc., etc., etc. So that's a decision that you have to make, and obviously, from a perspective of the company, you need to compare across all the different offerings. For the project, we just pick one particular category, but when you're doing the comparative product analysis from the perspective of the company, then you need to actually compare. You need to make a comparison across all the different offerings that we have. For example, 10 gram, 20 gram, 100 grams, 500 grams, 1 kg, the type of packet. So you need to create these 5 to 10 categories and then do an analysis across each category separately, and then assimilate the results and then do informed decision making. Because analyzing just one variant is not going to help you design the strategy for the whole brand. And then there was a huge challenge in bringing the data into the time series forecasting format. All of us know that time series forecasting requires us to shift the data across previous timestamps to create a supervised learning problem. And that was a big issue because the dates were not consistent. And the other issue was that the multiple suppliers are selling the same product on the same day. So the same product is being sold on the same day with multiple suppliers. So that means the same product has multiple entries on the same day, which is not what happens in a time series. So we need to aggregate the results of the multiple readings of the same product on one day we need to aggregate them together. For example, we can take the average. So for example, on the 19th of August 2020, Lipton 950 gram was being sold at multiple prices with different names, and there are multiple line items with the same date in the data. So obviously we need to do a lot of do a lot of wrangling in this case, because the same brand is being sold at different prices with different names. So this could be the way the products are being sold on Daraz. So the same product has different names and it is being sold at different prices. So that's something which is happening in this case on Daraz, and that's a very incredible type of problem, but that is what is happening, and we need to basically hone in. We need to aggregate the we need to make sure that we just have one product and one price per product on each day for a time series forecasting problem. Same products are listed on e-commerce sites like Daraz with different names. That's the problem that we have here. The product is the same, but the names are different. For instance, the same SKU name can be listed in a different case, different sequence, and with a different promotion. So when we do the scraping of the data, we scrape everything. I mean, but then we have to wrangle later on to understand that which product is being offered with different names on different prices on different promotions on the same day. So that becomes a huge challenge for the time series forecasting and also for the basic EDA. So that's something related to background. And now we come to this project methodology. Crafting the methodology took a lot of research and brainstorming, obviously. So the first thing to do was to identify the brand and the SKU. So the student was able to meet with the stakeholders of the business to identify the most strategic SKUs that are the direct competitors of Lipton brand. Okay. And we focused on the grammage. So the grammage was 950 grams because that seems to be the size that is very significant in sales. So they started off with that. So these are the 4 T brands: Vital, Kohinoor, Tapal, and Lipton. And obviously, you can see here Tapal is being offered in 950 grams in 3 different offerings, and Vital is being offered in 2 different offerings, and Lipton and Kohinoor are just being offered in 1 offering. So obviously, we need to do something about these 3 and 2 different offerings. We had to understand each column of the data to decide how we want to undertake the analysis. That seems to be a common approach. When you have small data, in this case, we do have small data. It's not terabytes of data or hundreds of gigabytes of data. So it's good to understand each column separately because it's going to just help you later on in the analysis. So these are some of the data wrangling steps that you might need to do. Filtered the data by brand, filtered the product name with only 950 gram SKUs, made the name consistent across the whole data set for one SKU. That's the problem that we saw earlier on, that we have different names for the same product. So we removed the different cases and promotions from the name. And then started off with plotting the frequency distribution of each brand to see the price ranges and the outliers. So the student has basically conducted this frequency distribution in multiple ways, as we will see right now. Majority products sell on a promotion on Daraz. There were a lot of bundle items as well, whereas we wanted to predict only single SKU, so we had to remove the bundles. So these are the type of decisions that the data scientist has to make. I mean, these are the assumptions which you do not want to tell the business guys because they are so insignificant and so small, but they still they might have an impact on the overall result. So you can't do anything other than to make these assumptions, and then you just come back and do some other assumption if this does not work out for you. So that's the way data science works. So dealt with the outliers, averaged out the prices on the same day, So that's what I was talking about, that when you have the same price, when you have multiple prices for the same product on one day, then you just average those price to get a single value. You can also take the median, uh, or you can take the average of the mean. And obviously for the time series forecasting problem, you need to put that in Python, in Pandas, and you need to create a separate data frame, which is, shifted, a data frame which is shifted basically for the time series supervised learning task. So we are into this, that we identified this, we did this wrangling first, and then we have these data cleansing tasks. And then obviously when the data is clean enough, then we can analyze the data and visualize it to understand many different types of things that you will see right now. And then obviously the last step and the most important one is to forecast the time series for the price, both for the competitor products and for the product of this company. So proceeded the time series analysis for Lipton and Tapal 950 gram, because Tapal and Lipton seems to be the best competitors of each other as compared to Kohinoor and Vital. So these two are more famous, so therefore we can forecast for them. So we adopted different models, like baseline model, which is the most simple model. Then we have the ARIMA and its counterparts. Then we have seasonal ARIMA with history and single day forecasting, which is same as ARIMA basically. Then forecasting with Facebook's profit, and then moving average. So it's sort of random here. We could start with like simple auto-regressive, then moving average, then ARMA, then ARIMA, or you could just start directly with ARIMA. It depends on what you want to do. In this case, what we could have done was that we could have also gone for VAR, which is variational auto-regression for forecasting multiple time series at the same time. But due to the lack of time, we were not able to do that. Obviously, the student had to struggle a lot in this project, and she got very good marks. But this is one thing which we could have tried as well. So, so regarding the data cleaning and preparation, we have already talked about the 4 SKUs that we have selected for the 4 different D brands. So we filtered this particular grammage, and we made the names unique, averaged out multiple prices on the same dates, and created the data frames. And then we did see missing values both within the data, and in case if any data is missing altogether in the series. So let's see if the student has done the missing value analysis for time series data, because we do need to have your homogeneous dates. If one date is missing, then definitely we need to forecast for that date, or we need to fill up the missing values for that date using different values, methods for time series data. Yeah, so yeah, we did that in this case. So this is the first analysis. So these are the SKUs that are being offered by Lipton. So you can see that there's a lot of SKUs being offered between 0 to 500 grams, and between 500 and 1000 as well, but just 1/3 of that. And very few SKUs being offered which are more than 1 kg. And obviously below 0 kg is nothing. We have just 0 there. So that shows that between 0 and 500 grams, there's lots of SKUs being offered. But we are focusing on the 950 gram one. The graph for Tapal has more peaks here. Like we have, it's dividing the 0 to 500 into 2 parts. So we have one peak from like 0 to maybe 300, and then another peak from 300 to 500. So I mean, that's a bit more diversity in the product range as compared to Lipton. Because we saw that the Tapal has, we saw above that Tapal has 3 variants in the range of 950, while Lipton has just 1. So it's just the way, the e-commerce guys are classifying their products. It depends on the company policy, really. All of us know that Lipton is a pretty stable brand. So They don't have that diverse offering as compared to Tapal, which seem to have lots of different product to offer. So that depends on the business, that that just increases your analysis that you have to do, and that also makes the running of the business more complicated if you have more offerings. So it's better to have less products and focus on them more for marketing and other purposes as compared to this case. But that's how it is with Tapal. So this is some a snapshot of the data set. You can see that we have brand ID, brand name, seller ID, seller name, the capture data, product SKU. So it's pretty complicated. This is the product name, the page URL, etc. So it's just a bit snapshot. Obviously, I told you we can't show you the real data. And the vital one, again, between 0 to 500, again, that's like pretty similar to Lipton, but the peak is pretty down. So it's pretty similar to Lipton's. I think they have less product offerings as compared to Lipton, but somehow they've not been able to maintain their quality as compared to Lipton and Tapal. And Kohinoor is just one big peak from 0 to 1000 or 1 kg, and the others are just very small peaks, like maybe the 4 kg or the 5 kg brand, something like that. So they are more stable with respect to their offerings, and they're focusing on just this particular section of products. So I think this is a big peak we need to classify, like Tapal and Lipton have done. So this gives us a general idea that basically we can see that the type, it's almost the same. So there's a huge peak between 0 and 1 kg or between 0 and 500 gram. So the different types of products that are being offered are not very different from each other. That's one analysis that we can gather from this one. And that makes things really complicated, because it does make things easy to compare and compete. But the problem is that, when you have the same thing which is being offered by different vendors, then there's a more risk to lose out on the competition. So you need to do something innovative, or you need to do something different to capture the attention of the user who has come to buy. In any case, so the second analysis is the frequency distribution of all brands as SKUs to see the price ranges. So in this case, so you can see in this case that this is the distribution histogram with respect to the price. So you don't have many products in the range of 600 to 800, or you can say you don't have that many data points, but the maximum data points are occurring in 800 to 900 rupees and 900 to 1000 rupees for the case of Lipton. And there seems to be gaps in here for the binning that this histogram has taken. So this is a pretty skewed distribution, which is not going to make our forecast simple. So we need to normalize it somehow. So we just filtered by removing the bars which are greater than 1400 rupees, because they do not represent the normal distribution of our data, of the price data. So now this seems more represent the normal curve as compared to the above case, which is definitely skewed. And obviously, the best thing to do is to test it using the statistical test, like the Anderson test, for example, and there are many other tests for checking the normality, and also we have the box plot, etc., etc. We also need to see whether this is the distribution which does follow the normal distribution, because it could follow the Poisson distribution, it could follow the binomial distribution or exponential distribution for that matter. So you need to have very good knowledge of probability distributions to understand what is happening here. But just for this case, let's assume that it is normal. So we do this filter. So it's between 800 to 1000. And for the Tapal, it's pretty strange. It's pretty, mostly it's 750 to 1000 rupees. Mostly their products are lying in this range. And then we have this big outlier towards the end. So we can just focus on the ones which are 800 to 1000 as similar to Tapal. So this is very, very skewed, similar to Lipton, sorry. So this is extremely skewed. And that's pretty strange that in spite of having many different offerings, the price distribution is very constricted in Tapal as compared to Lipton, which the prices are more diversified. So you can say this is a pretty normal histogram. The prices are more diversified, but in the case of Tapal, the prices are horribly aligned. This is extremely skewed on the negative side. There are no price tags here, which is pretty strange. In fact, this could be a data error, but I don't think so. There's a data entry error considering how much work we had to go through. So this is something which could be exploited by the business for their own benefit. That the product offerings are almost the same in the range of 0 to 500 or 1 kilogram, but the price distribution in Tapal is pretty restricted as compared to Lipton. For the Vital, it is more or less the same. So we have one bar in the range of 800 to 900, and the other bar you can say in the range of 925 to 950. So it's like maybe 800 to 950, something like that. So we have two bars here. So mostly the prices are occurring in this range, which is also similar to what is happening in Tapal. That's the thing. So you can see that that's also what's happening in Lipton, but we got these different bars together, which is making a better shape as compared to this. So it might be easy to forecast on Lipton. So it shows that their pricing strategy is more sophisticated as compared to the other brands right now. For the Kohinoor, Kohinoor has 3 different variants with these 3 different names for 950 gram. All these variants have a similar price range but different markets. But all of these are sold in bundles of 200 packs and 5 packs. But we don't want to look at bundles, so we want to remove Kohinoor because in bundles we have more than one product together, and we can't do that because we have individual products in the case of Vital, Lipton, and Tapal. So therefore, we are just removing Kohinoor from our analysis. In any case, this is their distribution. So this is also similar to Lipton. So if we remove this outlier, maybe this is also going to distribute. But you can see that in the case of Vital and also Tapal, when we do this filter, then the distribution is very, very skewed. So Tapal has a larger diversity of products and very constricted price ranges. So that's a very weak point that one can gather from Tapal's analysis. So we removed all the ones that are greater than 3,000 rupees, obviously, because that's not something that we want to do. So this is the graph that we get. So this is pretty good, but these big spaces in between, they are making things very complicated. So this is not a stable normal curve at all. It's not easy to forecast. So that's what we gather from scenario 2. And in the scenario 3, we are looking at this product price and the original product price. So this is the formula that we are looking at. Product price is the original price minus the product discount. So you can say this is the current product price and the original product price. So obviously, we would expect the original price to be always greater than the product price. So in some cases, we are getting this anomaly that the original price, the product price is greater than the product original price. So at some point that is happening. For example, in this case, you can see that this blue is more than that, but they should be the same. So typically the original price should be more, and the distance between them should tell you the discount. So you can see typically we don't have that many discounts, and in this case, when the blue is above the orange one, that represents an anomaly, and we need to investigate that with why this is happening. Maybe there's some sort of a negative discount, because instead of giving a discount, we are in fact giving a penalty to the user. So that is the only way that the product price can exceed the original price, or maybe it is some error in the calculation. So in the Tapal case, you can say that we can see that we have the more the amount of discount is not very different, but in the case of Lipton, again it's pretty sophisticated. But in the case of Tapal, you can see that there's a huge gap. So sometimes we have lots of discounts, sometimes less discount. So again, in the case of Tapal, we see something which is not as sophisticated as compared to Lipton in this case. And by the way, all the comments in this video are according to this analysis. They are not biased towards any particular brand. We are just observing. We are just analyzing based on our own observation. So the same sort of a similar trend for Vital, but Vital is not. There's not a huge gap here as compared to Tapal. As you can see, the gap is huge. So it's pretty okay. It's pretty consistent, and Kohinoor is also pretty consistent with respect to that. Okay. So this analysis tells us that in the case of Lipton, we are having a problem that the product price is exceeding the original product price, and the only way that is happening is that the users are not getting a discount. In fact, they're getting a penalty that they have to pay more than the original price. So we need to discover the reason for this. In my opinion, this could be a data entry error, or in my opinion, this could be some negative discount which is applied on the user. That's the case. So for the fourth scenario, we'll do the brand analysis across SKUs using the box plot. So you can see here that we have these 4 box plots and we have the product price. And when we have the box plot, we're looking more at more balanced box plots, right? So if the distribution is normal or seems normal, if the box seems normal along with its whiskers, so it means that it's more stable and more reliable even for forecasting. So you can see that the Kohinoor and Lipton boxes are pretty much the same size, but Kohinoor has several outliers as compared to Lipton. And the Vital Tea, again, Vital Tea and Tapal, they have similar boxes, but not as spread out as compared to Lipton and Kohinoor. So they can be at number 2, but Vital has more outliers as compared to Tapal. So Tapal is more stable as compared to Vital, and Lipton is more stable as compared to Kohinoor. And Lipton seems to have one, the product price spread is more, as we have seen in the histogram as well. So this basically this means that whatever Lipton is doing, it's going good as compared to others right now, as far as the costing is concerned. Yeah, so this is the Voilin plot. So the Voilin plot basically agrees that it shows the spread. So as compared to the Voilin plot, the spread of Tapal is more as compared to Lipton, but this is this is too much. This is not a normal Voilin plot, because it's the body of the Voilin is spreading out too much. We have to see the size which remains within limits. It looks exactly like a Voilin, and you can see that what looks exactly like a Voilin is Lipton. This Kohinoor definitely does not look like a Voilin, although in this case we were singing praises, but due to the outliers, it basically contracts the body of the Voilin, which is not a good sign. Okay. The length of the Voilin is same in Vital Tea, Lipton, and Tapal, but the spread is more in Tapal and white tea as compared to Lipton. So it seems more balanced. There is a spread, but the spread is not too high. So in this case, also the Royal Lipton seems to have one, and the number two is Vital. While in this case, Kohinoor seems to have one with respect to box plot. So different types of things are giving you different types of analysis. It depends on what you want to say. If you are looking at, you don't want to focus on the spread of the data, then you can say Lipton and number two is Vital. But if you're looking at the spread of the data, then you can say Lipton is number one and Tapal is number two. In any case, Tapal is not looking good as compared to Vital. And in this case, we were saying the opposite thing, that Tapal is better than Vital, but the violent plot is saying something else. So it depends on what you want to conclude. So what I will conclude here is that the Lipton is again the winner. Kohinoor definitely does not cut it because the spread of outliers is too high. And Vital here in this case is much better, seems to be better than Tapal, because they have almost the same length, but the spread of Tapal is more, which is sort of uncomfortable because it's too much, so it might give us a problem in forecasting. So these are the analysis that we have already done here. And then we have the specified SKUs. So we have the 950 grams here now for all the 40 brands. And this one is Lipton. So Lipton, again, you can see it is pretty constricted, and there is a huge outlier in Tapal, which is making this box plot, the whole box plot, very constricted due to this outlier, which is here. Vital, the above whisker is not there. Kohinoor, again, it seems okay. But to me, the things which seems more balanced between the box and the whisker and the outlier is again Lipton, as you can see here again, for this particular brand that we want to forecast. So the way the company is handling the Lipton brand is pretty good, but we cannot say that there is a huge difference in how the brands are being managed. There's a very minute difference, and that's why we need to go with time series forecasting. But it seems that the brand Lipton is being managed in a more sophisticated way as compared to the other brands, which have their own benefits as well. So that's what we can derive here. The median is the same for like Lipton and Tapal, is almost the same. Lipton is a bit higher than Tapal, which is a sort of disadvantage because the users are not going to care about the box plot. They're going to care about the price. So Lipton seems to have a higher price than this Tapal brand. And the median for Vital is nowhere. It's like it's the highest, I guess, because the median is here. It's the upper part of the box plot and the median are merged together. So the highest price is of Vital, and the lowest price I think is of Kohinoor. But the Kohinoor brand is being offered in bundles, and we don't want to go with that. We're just looking at individual prices. That's the thing. Typically, all of us know that Lipton is a bit expensive than the other brands. That's what the inclination is, and it depends on the taste actually. So I think the Lipton needs to understand, do something about their pricing strategy in order to ensure that the users are not running away because only because of the price, although they're doing things in a very sophisticated way. And I think that they are capturing the market as well based on the weights and the offerings and the price ranges. But in the end, the user looks at the price tag. And the box plot for Tapal is not bad. It's quite good as compared to the Lipton one. So it's at par. So it may be the case that users will run away and buy Tapal. That's the thing. So they might need to do something about that. So statistical test to see the normal distribution. So we have the Kolmogorov-Smirnov test, and we also have the Shapiro-Wilkinson test, where the p-value is very, very high. So we failed to reject the null hypothesis that the data is normally distributed. So that means we can't reject that. So the data is in this case. So in this case, the data is absolutely not normally distributed because that's the null hypothesis. And the quantile plot seems pretty good. So now value counts across SKUs. This sort of thing is, we can do much more here. We can do the same for all the brands. So you can run the Anderson test, and that is going to give you a much better idea of whether your data is normally distributed or not. And if it is not, then you can do some transformations to make it normally distributed before you go for time series forecasting. Or you might not decide to do anything, because in time series forecasting you have the differencing option to make the series stationary, but it's not stationary, and you have very sophisticated models which can do the forecast, but having a non-normal distributed data is not good. So the strategy that you use to cater for this depends on the data scientist, really. I can't say at this point of time what I will do. I will personally not make any changes in the data, because this quantile plot seems pretty good to me. It's quite normal. Yeah. So the value counts here. So we have 811 instances of this, and the value counts for Vital are not that much. It's almost half of Tapal and Lipton, and Kohinoor we have the maximum ones. Now that's pretty strange. Frequency of occurrences for all the SKUs. So which SKUs are listed most? So Kohinoor seems to be listed most. So that might be because Kohinoor is pushing it. It's several times more than Tapal and Lipton, but Tapal and Lipton are just at computing at par with each other, and they seem to be more sophisticated. So they seem to be highly competitive of each other. And Kohinoor and Vital are just coming out guns blazing in the arena, and they're trying to make their impact, and that's a good thing, because e-commerce is a very random type of scenario, so anything can happen any day. So that's what it is telling us. So I think Lipton and Tapal are more stable in this case with respect to their product offerings. Yeah, so these are the percentages again. So it's so we have this discount analysis by seeing the maximum unit discount on T SKUs. So we'll have this the discount analysis here. Yeah, so minimum discount is 0, which is understandable, and the maximum discount is 96%, and the mean product discount is 8%. That's pretty good, and the median is 9%. So we can, the discount analysis is another world. You just see that at what time of the day, at what types of discounts are being offered for a particular brand. You just monitor those discounts across several days, and then you understand what's their discounting strategy. So that's another type of analysis that one can do. In fact, you should segregate that from your normal price analysis, because discount and taxation and all these type of things are always a separate analysis, which have the potential to affect your pricing strategy quite a lot. So you have to analyze them separately. Like, for example, if you are forecasting the inventory, then in that case, what you need to do is that you need to make separate analysis for the manufacturing, delivery, and sales, and also the inventory stock. And then you combine them together to optimize the inventory from both sides. So it might involve some mathematical equations, it might involve machine learning, and some statistical analysis as well. So all of us know that forecasting the inventory level is not a piece of cake. So it's not easy. So the product with 96% discount is a Tapal variant, that is Tapal Days Them 950 gram tea. And it must have been a brief promotion for a brief time. So, uh, this this does not seem to be the normal behavior. You don't give a 96% discount. So it seems that Nepal is fighting to make its sales. So in fact, it could be a good strategy that you give such a huge discount for like 2 hours, and then you have sales increasing 100 times, and in the end you make a profit. So yeah, so there could be one strategy they're applying. So we'll have to analyze the discounting strategies separately. So these are the in-stock statistics. Majority of the times the tea products are in stock. So in stock, how many times? So mostly they are in stock, and sometimes they're not in stock. So that's the out of stock problem, which is not good, because I mean, you just want to remove this. You don't want this blue box to happen at all, to occur at all. You don't want an out of stock situation, which is the inventory problem that I was telling you about recently. So yeah, the problem is there. And then we have this ANOVA. So all of us know that ANOVA is basically giving you the analysis whether a KPI or numerical KPI, whether the mean of that KPI is varying significantly across different groups of some other variable. For example, across the different SKUs, whether the mean sale is different or not. So that is basically ANOVA that we want to do. And in this case, we have done the ANOVA for the product name, which is in our case like the 4 SKUs that we have of 950 grams, and the product original price. And you can see that the p-value is pretty significant. So that shows you that the original price of the product is varying significantly across the different product names, which is what we expect to happen, that the original price for each product is significantly different from all the other 3 products. So to find that out exactly, we need to run the Tukey test, which I think the student has not done, because the Tukey would have told us that the significant difference occurs between, for example, Lipton and Tapal, or it happens between Tapal and Kohinoor, or between Vital and Tapal for that matter. So that would have helped you to really understand the price difference across the different products. So if the significant difference occurs between which 2 products. So that's another knowledge that you want in order to design a comparative pricing strategy. And now we come to this time series forecasting part, which is the 12th thing that we have done here. So to convert the data into a supervised learning problem that I told you at the beginning of this video. And then obviously you analyze the time series. You want to analyze the series to see the trend and the stationarity. If the series is not stationary, then you want to make it stationary. You check the stationarity using the Dickey-Fuller test, which is the AD test. And then obviously we want to show the comparison of forecasts, or the comparison of this time series modeling for the different tea brands together. And then you also do this autocorrelation plots to understand the parameters for the ARIMA model. And then you create a baseline model, which is the basic model. The recent history is the best estimate for the future assumption. Okay, so that seems to be the basic rule of thumb in time series forecasting. Currently, the baseline model is just forecasting a single next day prediction. As we increase the forecasted steps of the baseline model, the error is expected to go up, which is obvious, because if you forecast into the very near future, which is like, for example, now costing, or the very near future, then you are liable to forecast in a small range with a very high confidence interval. But if you say that forecast for the next 5 months, then you're liable not to have very good accuracy. Yeah, so that's what you need to do. So we have talked about all these things before as well, ARIMA modeling, ACF plot, etc. So we do this ARIMA modeling with a single day forecasting. And this is the plain old ARIMA, but with incorporating history. So all of us know that the ARIMA model has these 3 parameters. P is determined, I think, through the partial autocorrelation plot. Q is determined through the autocorrelation plot. And D is the amount of referencing that you have done, which is either 1 or 2. And then obviously you fit the model and then use the model to make the forecast for the next few timestamps. And then you plot the series to see the actual versus the forecasted. Some people are finding out the best parameter values by trying out different values in a loop, and then checking out the parametric outputs for evaluating time series. For example, I think it's the AIC score that they want to minimize, I think. So yeah, you can do that. And remember that in the case of seasonal ARIMA, we have 6 parameters. So we have these 3 parameters for the normal time series, and then we have these 3 parameters again for the seasonal component of the time series. So yeah, we have to estimate 6 components in this case. And we all of us know about the Facebook's profit model, which you can apply, I think, in Python as well. So you can make a forecast using profit and then compare that with the forecast that you have done in Python on the traditional APIs that we have. And then for the moving average, we use the persistence model to calibrate the residuals. We saw the persistent model in my video of the ML1 course that I have already uploaded on YouTube. So you can search more about that later. So the persistence model is the baseline model in the normal time series forecasting case. We can use that to calibrate the residuals of the time series. And then we train the moving average model on these residuals from the persistent model. And then we can correct the prediction by using the autoregressive forecast residuals from the MA model. So that seems to be the normal way of using this moving average model. And then obviously we can plot the RMSE scores. So ARIMA with history is giving us the minimum RMSE, as is the moving average model. And seasonal ARIMA and profit and ARIMA models and baseline models have a higher RMSE as compared to ARIMA with history. So we take the history there. So let me just check the ARIMA with history option. So here we have the history would allow the model to forecast into the future with immediate previous history and hence producing good predictions. So this is different from the traditional ARIMA, because in the history case we are forecasting with immediate previous history in mind. Okay, which is not what happens in the normal case. In the normal case, we don't take the immediate history. So this could be some other model. This is probably some variant which the student has experimented with some different parameters. So let's check those later on. So we have seen this ARIMA with history and the moving average model are giving much better results as compared to the other 3 or 4 options. This is for the case of Lipton, and for the case of Tapal, the minimum is being given by the baseline model, which is I think we can take the ARIMA as the minimum one in this case, or maybe even the seasonal ARIMA. So we have 2 different performance for the different T brands. So that means one algorithm does not suit all. So we have to see which algorithm fits where. So seasonal ARIMA performed better on Tapal data than on Lipton data. So that could be, obviously that is justified because their pricing the pricing strategy of each brand is definitely different, as we have also seen in the histograms and the violin cards. So this just concurs with that. So this is price forecasting was the most important KSA problem I could identify from the data set. This is the requirement that I gave to the students. So there are two prices for the original price and the discounted price. So the challenge being faced is to assign prices or discounts to their tea products on e-commerce platforms that we have done before as well. Lipton struggles to get the market share compared to local tea competitors like Tapal and Vital, who have an edge because of their blend. So now we have this problem specified very clearly, and we have seen that the data for Lipton is pretty follows the statistical requirements for the normalized data as compared to Tapal and Vital, but Tapal and Vital have a better distribution of the product offerings as well as price offerings. Although their histograms are pretty, they're pretty skewed, but they're able to capture the market, which is what I was telling you when we were analyzing the box plots for the 950 gram tea, 950 gram variants of these or the four companies. Lipton is a bit expensive than all the other four brands. Sorry, barring Kohinoor, that's expensive than Tapal and Vital, and that is what is written here. That's because it's taking an edge. So the problem that we have to solve is that we are adopting a very consistent strategy for generating the data, but unfortunately, what Tapal and Vital are doing as compared to Lipton is that they are making they're making more noise on that e-commerce platform as compared to Lipton. So maybe the Lipton strategy works maybe on a brick and mortar store, in which the user just goes and picks up the bottle of half a kg of tea because he or she has been buying that for the last 15 years. But in the case of e-commerce, the scenario changes completely. So one who moves most is the one who is most profitable. So it is integral to know the right prices so that they can tap more customers. So what Lipton needs to do is to reduce the price and increase the product offering, or maybe give more promotions if they don't want to mess with their pricing strategy, which seems to me pretty sophisticated. So our recommendation would be to go for more promotions, because Lipton has its brand name with itself. So it's expected to get more customers even if they have spent a bit more, but they need to promote. They need to pick up some intelligent promotions online. Yeah, so it's written here. So this is the pipeline. So the TSF forecast is helping us forecast the next prices based on past trends for both Lipton and Tapal. ABC can see the next prices of Tapal and can take strategic decision to amend its prices accordingly. That's a big deal. That's a pretty big deal. Even though this is a course project, this is not something which could be used directly in the company. But as the employee, as the student was herself an employee, so she could take this stuff and perfect it within 1 week and do this. So it's a big deal to forecast the prices of your competitors in advance, even if they're just within a confidence interval and they're not 100% accurate, they're just 85% accurate, but still that's a big deal. So you can understand them better what's happening. So you can evaluate your forecast for the next maybe 15 days. And then when you're confident about them, then you can use those values in advance to determine your own pricing strategy at runtime and adjust the prices. And Lipton needs to go a bit down. Maybe they can remove some of their products to save money. And they can make some promotions or discounts, make them more prominent, do some SEO, etc. That's the thing. Yeah, this is including. So So I've asked the question that suppose your model is deployed in industry and generates predictions on live test data. What if the distribution of the original data changes? What if Daraz, or what if Tapal or Vital or Lipton, they suddenly change their pricing strategy considerably? Then what happens to your forecast? Your forecast is going to go down. So how will you update your model? So first of all, I will increase the data size, change the orders in DSF. There's something which is called autonomous machine learning, but autonomous machine learning is easier said than done. You need to be very careful in what you're doing there. So yes, in my opinion, one should have an automated routine which is going to update your model and relearn it from time to time. Yeah. So now the effect of this project is this one, which I want to stress to the viewers. We will receive this Daraz data every month from now onwards. Okay. We will ingest it in our models and make prediction for the next 30 days and share it with the business to take their pricing decisions. So that's the impact which academia can make in the industry. So this is a product, this is the project of a course, right? But now the employee is trained 100% on what she needs to do and how she needs to do it. So the model is made, and that is pretty helpful. We will incorporate Vital and Kohinoor, which they were not doing previously. We'll try to apply other techniques to split the promotion from the name and analyze that. So that's a wrangling step. And try some other forecasting models too. That's where you can go for the war model. Yeah, so profit we ran in the Google's Colab, but the performance of profit was not pretty good as compared to the seasonal REMA model. So this is the profits performance. Let's see what so this is the forecast that is coming up. That seems pretty normal. Red is the test set and blue is the prediction. So the prediction on the test set is not pretty good by profit. Profit cannot perfectly capture the trend, both the upper trend as well as the lower trend. The forecast does not follow the true value either. Actually, the problem in this case is that you need to tune the models. But I think the student here has not actually tuned it properly. Otherwise, profit is not something which is a light thing. You can tune profit definitely. I know many people who are using profit in the industry and they're doing big things. So yeah, you can do that, but our recommendation is always to develop your own pipeline. Don't use some API like profit, which is a complete solution. So it's better to write your own code, understand things, do the differencing, etc. So this is these are the notebooks which I will put online, and you can see the link for these inshallah on the YouTube video. So you can see we have the student has developed some templates which I've always asked the student to do before loading the data, for doing this, checking the details, the statistical descriptive statistics. There's a piece of cake, listing down the columns, seeing the head and tails, filling up the missing values, drawing these sort of curves. You can always have this, you always need to have templates. So this is something which we did not discuss in the report because everything cannot be put there. And the fact that we have the product discounted price more than the original price is also strange. That means you did a negative discount. So these are all the things that we saw in the report. So you can go through them and execute. But if someone wants to do this, then you have to scrape your own data because I'm not allowed to share the data with the community. So these are the same graphs that we saw earlier on. The quantile plots, etc., etc. So you can see there are some errors as well. So we have this ANOVA in more detail, and you can just go through them. So if you want to forecast for the Lipton, so we can see the head and the tail. So this is the plot, which is not looking like a time series plot in any case. So we can see that The series here in this case is not stationary. So we need to make the series stationary. So first, what we have done is that we have plotted the mean. I don't think the mean is looking consistent here. So Lipton series is like this. So we have this baseline model. The recent history is the best estimate for the future assumption. So we are just looking at, we are just shifted one timestamp into the past. So actual price and the forecasted price like this. We split into train and test. Then we have this persistent model which just returns the value X. Just see my YouTube lectures on the time series forecasting for ML1 course, which I taught in Spin 2021 to understand what's the persistent model. These are the forecast here. And then we have these autocorrelation plots. So we can see that the significant and lag 1, 2, 3, 4, 5, 6. So that's pretty consistent data. So we have two autocorrelation plots. So the interpretation is written here. And the partial autocorrelation is significant at 1. So it seems that we can take the value of P and Q as 1 and 1. But again, you can try out different values to find out the best AIC value which is there. We fit these up. So these are different graphs that are there. So these are the outputs of the residual models and the histogram plus estimated density, normal quantile. So these are the outputs of the forecast. And the forecast is pretty strange with a single day forecast and history. So yeah, so this looks pretty good here, single day forecast with history. The history basically means just, I think, the previous timestamp. Okay. So we can do the grid search to find out the different values of PDQ. And obviously we can check the mean squared error which is being reduced. So there's a lot of warnings here. There might be some errors as well. So just have to see what is happening here. So we are looking at this. Yeah, so let's see which is there. 212 from this and used it in the ARIMA model above. So this is the seasonal decomposition. Obviously, all of us know about that. So this is the trend here. This is the seasonality which is there. This is the, I think this is the cyclic pattern. And this one is the residual. So this does not look like white noise. So that's okay then. The forecast actual price. This is not going in a good direction. Trying out Facebook profit. So we have already seen these graphs. So I invite the viewers to go through this in detail because I'm not going to discuss this. What is happening here? RMSE 7.052 is pretty good in this case. But it seems that the ARIMA, when we take the history as just one timestamp into the past and use it to predict the next timestamp, that seems to work very good for the Lipton case. Okay. And for the case of Tapal, so we have done the same things here. We just do the baseline model and the basic wrangling. And then we have the ARIMA model. Because once you have the template, then you can use that for any other T brands. We have the correlograms. And then we have this forecasting between ARIMA model. Just one look at the forecast. So this one is with history and single point forecast. So this is also pretty good. So that seems to work well here, but I think a seasonal ARIMA did better in this case. Trying out Facebook profit. I have not seen the graph for seasonal ARIMA. Yeah, so this is the typical seasonal ARIMA, but this is not good. This is not a good forecast. So I think in both the cases, the ARIMA is winning out. ARIMA is winning with respect to just one point of history initially. So we have some errors here. And we have the moving average model. So this is pretty. So this is pretty good. So we have the RMSE test RMSE of 40.561, but I think this is more than for the case of ARIMA with history, the traditional ARIMA with the history option. So there's a lot of work that has been done in this project, and it's I think I have to appreciate what the student has done, but there's still a lot of work done to formalize this time series in a better way. You need to have templates and you need to have a single flow of things. So I invite the viewers to go through this and just use it for their own benefit, remove the errors. And many students in this course were not exactly coming from the CS background. So this is a big improvement that what they're doing, what they're trying to achieve. So I think yeah, this has been a very, very critical project, and I'm 100% sure that they're using it now in their own in their own company. So thanks a lot for watching, and I'll inshallah ta'ala continue to upload more videos of good projects and put the code online for you to use. Thanks a lot for watching. Thank you very much.